Okay, and we will wrap up Chapter 8 with Section 8.3, our learning targets. By the end of this video, we should be able to determine whether the conditions are met for constructing a confidence interval about a difference between two proportions, and construct and interpret a confidence interval for a difference between two proportions. So the first one, looking at conditions, you'll see this is very similar to our conditions when we are just trying to construct a confidence interval for a proportion. So we still want to make sure that the data comes from two independent random samples or from two groups in a randomized experiment. Then if it comes from two independent random samples, we want to make sure that 10% condition is met because most of the time we are sampling without replacement. And so we need to check that for both of these samples. So show that each sample N is less than or equal to 10% of our population. And again, that's so that we can say that it's independent. And then in order to say it's approximately normal, we need to check our large counts. We need to have at least 10 successes and failures for each sample. So N times P is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. And you will want to round these numbers to the nearest integer, especially if you plan to use your calculator, which we will talk about when we talk about the technology corner. Okay, and again, that's so we can say it's an approximate normal distribution, allowing us to use our z-star or to approximate the area for our confidence intervals. Okay, so let's take a look at an example of checking the conditions. So do you prefer brand names checking conditions? So a Harris Interactive survey asked independent random samples of adults from the United States and Germany about the importance of brand names when buying clothes. Of the 2,309 U.S. adults surveyed, 26% said their brand names were important, compared with 22% of the 1,058 German adults surveyed. And they defined PU, the true proportion of all U.S. adults who think brand names are important when buying clothes, and PG, the true proportion of all German adults who think that brand names are important when buying clothes. So we want to check the conditions for calculating a confidence interval for PU minus PG. We want to see if they're met. So first off, random. We were told that they were independent random samples from the United States and from Germany. So we want to include our numbers there. So we can just restate what we were given in our problem. So make sure you're mentioning the independent random samples. And then the 10% condition. So we want to check to see, yes, 2,309 is less than 10% of all U.S. adults, and 1,058 is less than 10% of all German adults. Then checking large counts. We want to check that N times P hat is greater than or equal to 10 for each of our counts. Successes, so N. For our first sample, we have 2,309 U.S. adults surveyed, and 26% said that they were important, so that would be approximately 600 adults. And then when we take 600 away from the 2,309, we have 1,709 for N times 1 minus P. And then for German adults, we have N times P is equal to approximately 233. And N times 1 minus P is equal to approximately 825. So since all of them are greater than or equal to 10, we are able to say that the distribution is approximately normal. So now that we have those conditions met, let's take a look at our formulas for doing the confidence interval. On your formula sheet, you are given, again, the confidence interval is the statistic of interest plus or minus the critical value, so our z-star, times our standard error of our statistic. So when we have a difference of two populations, we can go ahead and subtract to find the difference of the proportions. And then because we don't have the population, notice it as a p hat times 1 minus p hat over the n for the first group, and then notice it's a plus sign, p hat times 1 minus p hat divided by our sample size of the second sample for the second part. So be really careful when you're doing that, and remember the z-star is that critical value that corresponds to our confidence interval percentage. So if we look back at that example, if we want to calculate a 95% interval for that, the proportion of the United States minus the proportion of German for the brand name example, we can see when we subtract, we get 0.04, and then 1.96, remember, comes from doing, it was a 95% interval, so an inverse norm, 95% would mean half of that, and then so half of 5%, standard, the mean of 0 and standard deviation of 1, there's where that 1.96 comes from, and then times, and then we can see we have our p times 1 minus p divided by our sample size for the United States, and then plus the p times 1 minus p for your German sample divided by the total in that sample. So we get a confidence interval that is 4 plus or minus 0.04 minus plus or minus 0.03, which is 0.01 to 0.07. So when we interpret it, remember we're following that prescribed sentence. We are 95% confident that the interval from 0.01 to 0.07 captures PU minus PG, the difference in true proportion of all U.S. adults and German adults who think brand names are important when buying clothing. So remember the interval. If we were to take many samples and of the same size and follow the same procedures, we would be 95% confident. The confidence intervals, approximately 95% of them would capture the true difference in the proportions of U.S. adults and German adults who think brand names are important when buying clothes. So this does not include 0, which would be a no difference as a plausible value. So we do have convincing evidence of a difference between the population proportions. And so we would be able to say that any value between 0.01 and 0.07 is what we believe to be how many percentage points higher than the U.S. Than the Germans. Okay, remember that is percentage points higher, so be very careful that you don't just flip that to a percent higher, because it does not mean the same thing. And make sure that you are defining the parameters when you are describing your sample proportion. Okay, so just like before, we're going to want to follow our 4-step process when we are asked to do this. So we'll want to state the parameter we're estimating and the confidence level at which we're doing it at. We will want to plan and check the conditions in that plan step. After we identify the method that we're using, in the do step, we want to go ahead and perform the calculations and then conclude to interpret. So there are some exceptions when you are working with experiments. Experiments are commonly used and they're recruited using volunteers. So remember, since the subjects are not randomly selected, we can only generalize to people that are similar to the people that are being in the experiment, just like before, and cause and effect can be applied to people like those. And then in the random condition, we do not need to meet the 10% condition when we're analyzing experiment. But we do need to check our large counts. So do make sure that your volunteers are randomly assigned to their treatments, just like they were for a good experiment back in chapter 4 when we started this year. Okay, so let's do an example of pulling all of these steps together. So in this example, we are going to take a look at back pain. So patients with lower back pain are often given non-steroidal anti-inflammatories. There are NSAIDs like naproxen to ease their pain. Researchers wondering if Valium along with the naproxen would affect pain relief. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of 2 treatments, naproxen and Valium or naproxen and a placebo. After 1 week, 39 of the 57 subjects who took naproxen and Valium reported reduced lower back pain, compared with 43 of the 55 in the naproxen and placebo. So we want to first construct and interpret a 99% confidence interval for the difference in the proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium versus taking naproxen and a placebo. So state. 99% confidence interval for our P1 minus P2, where P1 is the true proportion of patients like those who would report lower back pain after taking naproxen Valium for 1 week, and P sub 2 is the true proportion of patients like those who would report reduced lower back pain after taking naproxen and placebo for 1 week. So we need to make sure that we are including not just that it's subtraction in the order, but what each of those things represent. Plan. We're going to do a 2-sample Z interval for our P1 minus P2. Because it's an experiment, we do not need to check the 10% condition. So for random, they were randomly assigned to take the naproxen Valium or the naproxen placebo. Our large counts, we had originally 39. 39 who said they had lower back pain, reduced lower back pain. So 57 minus 39 leaves us with 18 for the failures, and then 43 successes for the other group, and 55 minus 43 for 12 for the failures. So all of those counts are above 10. So far, so good. We can go ahead and do this. So now we need to find those p-values by 39 over 57 to get our 0.684 and 43 over 55. So we do want to identify our p-hats that we're using, and we should definitely show our calculation. Remember the C star for this one, because it's a 99%, we would have 1% left, so we can do an inverse norm again. And this time, half of 1%, so 0.005 and 0.1, or we can go to the table to get our 2.576. If we use a little bit of a different number here, of course, it'll give us a little bit of a different number. So just want to kind of point that out in case you use something different. That's quite all right. And I also want to point out the tech corner on this. I know it's on the next slide, but a lot of times in this do statement, we can do it absolutely. When we do our 0.684 minus 0.782, we can get our negative 0.098. And then when we put in this 2.56576 times the square root of 0.684 times 0.316, because 1 minus 0.684, and then divided by 57 plus 0.782 times 1 minus that would be the 0.218, and then divided by, that's supposed to be an 8 there, divided by 55, and then when we hit enter, that's where that 2.214 could come from. And then when we take our negative 0.098 and then add, we get our right side. And if we take our negative 0.098 minus 0.214, we can get our left side. So that's one way to find our confidence interval. And then we would interpret, and we would say the conclusion is we are 99% confident that the interval that we found, negative 0.312 to 0.116, captures the true difference between patients like those who would report reduced back pain after taking naproxen Valium versus taking naproxen and placebo for a week. And then our interpretation, they asked us to, in part B, based on the confidence interval, what conclusion can you make about taking the Valium along with naproxen? And because 0 is in our interval, it is possible that there is no difference. So because it's plausible, we don't have convincing evidence that taking Valium along with naproxen affects pain relief, because if 0 is part of it, there could be no difference. Let's go and we'll take a look at that tech corner and we'll go through how to do this on the calculator. So you can see that this tech corner does take you through the process. I'm going to do it with you at the same time that you're looking at those steps. So the first thing we're going to do is press stat. We're going to move over to test. And then we need to look for a 2 sample z interval or 2 proportion because we are doing a proportion. So 2 proportion z interval. There it is. And we are doing the 39 out of 57 for our approximate in the value, and then 43 out of 55 for an approximate in the placebo, and then we wanted a 99% confidence interval. So now that we have everything in and we hit calculate, we can see it gives us our interval right up here at top, and it gives us our P1, P hat 1, and a P hat 2. So those are things that we would want to report. So you can use this for your do step whenever you are constructing your confidence interval. Okay, so let's take a look back at our learning targets. So hopefully after going through those examples, we can determine whether or not conditions are met, and we can also construct and interpret the confidence interval.